Hello, everyone, and welcome once again to an interesting chemistry class on how to balance redox reactions in basic solution. Without further ado, let's get down to business. Before we begin to balance this reaction in basic solution, there are certain things I would love you to know. The first one is that to balance a chemical reaction or a redox reaction in basic solution, you are basically going to start from acidic. You're going to go from acidic to basic. Okay? You begin from acidic to basic. So you're going to go from acidic to basic. This means that we're going to balance this reaction first in acidic solution, and then from there, we go to basic. So you're basically going to add like one or two extra steps to go from acidic to basic. Trust me, it's not really hard. This is what we can really do. And I want you to pay attention and get your pen and paper. Follow me as I solve this very problem right here. Now, that's the first thing that you need to know. The second thing that you also need to know is that if you have something like a negative, this thing means negative one. Just like here, you have Br minus. It means that this bromine has a negative one charge, right? Now, this one here, MnO4, has a negative charge. It means negative one as well. So it means that this compound here has a negative one charge. And on the right here, we have MnO2. There is neither a plus nor a minus, and that means that the total charge of this compound is 0. For the next one here, we have our bromine, okay, BrO3, right? Now, this negative here means that it has an overall charge of -1, just as I've written here. Now, in redox reaction, we are not only concerned about the atoms, but the charges as well. If you look at these charges here, on the left we have negative, so that's -2. This is a negative. Okay, this one is a -1, is a -1. It means that on the left we have an overall charge or overall net charge of -2. On the right we have a net charge of 1, right? This is -1 rather, not a 1. We have a net charge of -1, which means that the charges are not balanced. We're not only concerned about the atoms, but the charges as well. Now, we're now going to balance this to make sure that the atoms and the charges are all balanced. Whether it's a +2, whether it's a -2, whatever it might be, the idea here or the goal here is to make sure that your atoms and your charges are balanced. How do we balance this redox reaction before us? Well, we're going to use the half reaction method where we pick like terms. I will say like terms in this case. So we have our reaction 1. This is Br and Br, they go together. For the second one, we have MnO4 and MnO2, they are the same. Please do not pick Br and MnO2, they are not the same. It has to be Br and Br, MnO4 and MnO2, not the other way around. Now we're going to use the half reaction method, like I said, where we split them into 2. And what do we do in this very case? I'm going to start with the Br minus. So this Br minus here, I'll begin with this. Here we have our Br minus. I'll put my arrow. This is our first reaction, and I'll copy this one down. This BrO3 minus. We have the BrO3 minus. Now, I want you to understand something. Whenever you're balancing redox reactions, you must always make sure you balance atoms that are not hydrogen or oxygen first. For example, here we have no hydrogen, we have only oxygen and bromine. So first of all, we balance the bromine before we balance the oxygen. Now here we have one atom of bromine on the left and one atom of bromine on the right. It means that the bromine are balanced. Now, if you look at here closely, you discover that this bromine has 3 atoms of oxygen attached to it. But we don't have an oxygen here, let alone 3. So what do we do right now? In redox reaction, you can add water, right? You can add water. If you add water right now, you introduce oxygen on the left. But the question now is, how many are we adding? We're adding three, right? Because if you add three water molecules, let's say 3H2O, right? You're not going to have 3 times 1 oxygen will give you a 3. This means that we now have 3 atoms of oxygen on the left and 3 on the right. Okay, so that's how to balance the oxygen atoms. You must always add H2O to balance the oxygen atoms, right? But you should also understand that when you introduce H2O in the reaction, you have also introduced at the same time hydrogen. You've seen here that we have 3 times 2, and that makes it 6 atoms of hydrogen on the left, but we don't have any hydrogen on the right. Now, what do? We're now going to add hydrogen ions. How many of them? 6H plus. Okay, remember that we're going from acidic to basic, and that means that if you introduce hydrogen ions, it means that you've added an acid. So it's now you've now started balancing in acidic solution. Okay, now from here we can now go and balance for the basic solution. Now let's now count our charges to know. Let's count our atoms to know whether they're balanced or not. We have 3 atoms of hydrogen plus times 2 here. That gives you a 6. We have a 6 on the right. We have one bromine, one bromine. We have 3 atoms of oxygen on the left, 3 atoms on the right. Now they are balanced. The atoms are balanced. Now let's go ahead and balance the charges. Remember that this negative here means a negative 1. This is also a negative 1. This one right here now becomes 6 times plus 1. That gives you a 6. Okay? This 6, the coefficients, the numbers in front of all these compounds affects the charges, and that's what you need to know. Now, 6 times 1 will give you a 6. Okay, here we have a minus 1 plus 6. That's equal to what? It's a 5, right? Now, on the left here, we have minus 1 from here. We only have a minus 1. Now, we're going to ask ourselves, how many electrons am I going to add to the more positive side that if I add it to this right here, which is a 5, I'm going to get a negative 1. So don't even make the mistake of adding a 5. Don't say 5 electrons, because if you add 5 electrons to the right, it's not going to be 5 here plus minus 5, or 5 minus 5 gives you a 0. For example, if you add 5e minus here, it's not going to be the 5 here minus 5, because electrons are negatively charged, it's going to give you a 0. You have a 0 on the right, but you have a minus 1 on the left. You end up getting a wrong solution. Therefore, we cannot add a 5. We can't add 5 electrons. We must add more than 5 in order to make it a negative 1. So this is simple arithmetic, and I believe we've understood this. So here now, we're going to add 6e minus, right? If you add 6 electrons on the right, what's going to happen? You now have 5 minus 6 is equal to what? Negative 1. So that's all we need. Once you add 6 electrons, it will cancel out the 5, and you still have a negative 1 charge on the right. Therefore, this now becomes negative 1 on the right and negative 1 on the left, which means that our atoms and our electrons or charges are balanced. Now, we can now ignore this one and continue with our journey by balancing the next half reaction. Let me copy it down. Here we have MnO4 minus, and we have our arrow. Now what's next there? We have MnO2. Okay, remember that this MnO2 does not have any charge. The net charge is 0, while this one here has a minus 1 charge. Now, what do we do next? Like I said, whenever you're balancing this, you must always balance the atoms that are not either hydrogen or oxygen first. Now the Mn, we have one on the left. We also have one on the right. Now what do we do with this? Since the manganese atoms are balanced, we can now go ahead and balance the oxygen. On the left, we have 4 atoms of oxygen. On the right, we only have 2. What do? We're going to add H2O, right? Like I said, here we add H2O, but the question right now is how many molecules are we adding? We added 2 H2O. Why do we add a 2? Because this 2 here affects the oxygen, and now we now have 2 plus 2. So this is a 2 now plus 2. That makes it a 4 on the right and a 4 now on the left, which means that the oxygen atoms are balanced. And remember that when you introduce or when you add water to the reaction, you're going to add or introduce hydrogen. Have you seen? So here we have 2 times 2 atoms of hydrogen, and that gives you a 4, which means that on the left hand side, just like we did for this one, whenever you want to introduce hydrogen, it has to be a H plus because we're going from acidic to basic. So right now, we're going to add 4 H plus on the left side to balance the 4 atoms of hydrogen on the right. Okay, so we add the 4 H plus. Now, what now happens next? Let's check if our atoms are balanced before we proceed to balance the charges. Here we have 4 atoms of hydrogen on the left, 4 on the right. We have 1 atom of manganese on the left, 1 atom on the right. We have 4 atoms of oxygen on the left. We have 2 plus 2, and that gives us a 4, which means that the atoms are balanced. Now, let's work on the charges. Look at this here. We have 4H plus, right? This 4H plus right here, this 4 affects the plus 1. Remember I said if whenever you have a plus, this is equal to a plus 1 charge, okay? And whenever you have a minus, it's equal to what? A minus 1. So you need to know all these things whenever you're balancing this. All right. So the 4 affects the plus 1 charge, and here we have a minus, right? This now becomes 4 minus 1. This is equal to 3. Okay, this means that you have a net charge of 3 on the left and 0 on the right, because the MnO2 does not have any charge. This is 0. The 2H2O does not also have any charge. This is also a 0. This means that you have a 3 on the left and a 0 on the right. This implies that the charges are not balanced. Therefore, we ask ourselves, how many electrons are we to add to the more positive side in such that since you have a 0 on the right, you end up having a 0 as well on the left. So what number is that? Since we have a plus 3 charge on the left, we now say we're adding 3E minus, right? Now, we have a plus 3 charge on the left. This now becomes 3 minus 3. Remember that electrons are negatively charged. This is equal to what? 0. So adding a 3E minus or 3 electrons on the left gives you a net charge of 0 on the left, and this one here is also a net charge of 0 on the right. So this now is 0 and 0, and that means that they are now balanced. The charges are now balanced. Now, what next do we do at this very point? We can now go ahead and add them together. But before we add them together, we must make sure that the number of electrons on both sides are equal. So I'm going to copy this down again. Let me copy this down. Here we have 3H2O. This is our first reaction, plus Br minus. We put our arrow. We have BrO3 minus. We have plus 6H plus 6E minus. These are 6 electrons. And for the second one here, we have 3E minus plus 4H plus MnO4 minus. We put our arrow. And right here we have MnO2 plus 2H2O. All right. Now, if you look at this right here, you discover something. You discover that the electrons here on the left and the one on the right are not the same. They're not equal, right? Now you have to ask yourself, what number am I going to multiply this by in such that if I multiply this second reaction by that number, the number of electrons here, okay, what is in the second reaction will be the same with the first reaction. Remember that they must be the same because these electrons are not supposed to appear in your final solution. We have to cancel out what appears on both sides. We have electrons appearing on the first reaction and on the second reaction. So you must cancel them out. That's the rule. And if it appears in your final solution, then it is not acceptable. Now, what are we going to do right now? We have to multiply the second reaction by 2. Why is it so? Because if we multiply these 3 electrons by 2, we now have a 6, okay? We're not going to have a 6 here and a 6 right here, okay? So they're going to be equal. Now, let's copy the first one down. Here we have 3H2O plus Br minus, put the arrow. We have BrO3 minus plus 6H plus 6E minus. Now, the next one here is going to be multiplied by 2. So this 2 will affect everything in this bracket. Everything will be affected by the 2. So we say 2 times 3E minus will give us 6E minus plus 2 times a 4H plus will give you 8H plus 2 times MnO4 will give you 2MnO4 minus, and then the 2 multiplied by the MnO2 will give you 2MnO2 plus the 2 multiplied by the 2H2O gives you 4H2O. Okay, now we've reached at this very point. What's the next thing to do? We're not going to cancel out what appears twice on both sides, right? So let's go ahead and draw our line to indicate that we are adding the reaction. This is a 2 right here. So 6A minus appears in the first reaction. It also appears in the second reaction. We cancel them out. So you must cancel out whatever appears on both sides. Let me use the red pen for clarity. We cancel out the 6A minus. We cancel out the 6A minus. Now we ask ourselves again, what again appears in or on both reactions? We've seen that H plus appears here. There's a H plus here. There's also a H plus here. So we can simply cancel out the 6H plus and remove 6 from this 8 here. So if you cancel out the 6 from the first reaction, you also remove 6 from the second reaction. And when you remove 6 from the second reaction, you'll be left with a 2. Now, let's also check for what else appears on both sides. We have H2O appearing in the first reaction here and also in the second reaction. So what do? We cancel out the 3, H2O, and from the 4 here, we remove a 3. We're now left with 1. Okay? So when you cancel out what appears on both sides, suppose as 3 is smaller than 4, we cancel out the 3 and remove 3 from 4, you're not left with 1. Now, once you're done with this, whatever remains, you can copy them down. So what do we have here? Let's add them. And how do we add this reaction? We shall start, let's begin from this one here. So we add it this way. Everything on the left, okay, before the arrow goes to the left, it comes here. And everything after the arrow, okay, goes to the right. So this part here is for our right. So I will say this is our right and this is our left. So everything here would be written down here, while everything on the right will also be written after the arrow. All right, let's now add them together. I'm going to begin from the bromine. So we have Br minus plus, what else is remaining? We now have 2H plus. Here we have 2H plus. We now have 2MnO4 plus 2MnO4 minus. We put our arrow and also drop everything here down. Let's begin from the BrO3 minus. Here we have BrO3 minus. What next? Plus. Here we have 2MnO2 plus what's remaining here is H2O. We write our H2O. At this point, it is balanced in acidic solution, right? But we're not looking for the acidic solution. How am I sure that it's balanced in acidic solution? It's because of this H plus. So if your answer contains a H plus, it means that it's balanced in acidic solution. But we have 2 or 3 more extra steps to take in order to balance it in basic solution. But before we do that, or before we take those steps, let's count our atoms and charges to be sure that we're getting it right. On the left here, we have 1 bromine atom. We have a 1 here. We also have a 1 bromine atom here. On the left, we have 2 hydrogen atoms, okay? 2 hydrogen atoms. And on the right, we have 2 hydrogen atoms as well. For the manganese, we have 2 atoms of manganese. This, to remember, it affects the manganese. So we have 2 atoms of manganese. And on the right, we also have 2. Okay. Now, for the oxygen, we have 2 times 4. That gives you an 8. Here we have 2 here. Okay. This 2 times this 2 gives you a 4. 4 plus this 3 here gives you a 7. And then 7 plus 1 here gives you an 8, which means that the atoms are balanced. Now let's check the charges. Here we have a 2 plus, okay? So 2 times plus 1, remember I said that if you have a plus, it means plus 1. So 2 times plus 1 is a 2. And here we have 2 times negative 1. It gives you a negative 2. Therefore, we have 2 minus 2 is equal to what? 0. Now, for here, we have a minus 1 charge for the bromine on the left remaining. After this one, remember that this 2, the 2 times 1 and the 2 times negative 1, they will give you 2 minus 2, and that gives you a 0. You're not left with a negative 1 on the bromine. And right here, you also have a negative 1. It means that the atoms and the charges are balanced because we have the same number of atoms on both sides of the reaction, and we also have a negative 1 on the left and a negative 1 on the right for the charges, which means we are on the right track. Now, how do we continue with this solution to balance for basic? We're now going to introduce OH minus on both sides. Okay, remember I said for you to balance in basic, your answer must have an OH minus, which means that this H plus is going to disappear. And finally, we must have an OH minus. If you have no OH minus, then your solution is actually wrong. Now, how do we do this? We're going to introduce OH minus on both sides of the reaction. That's always how to do it. So whenever they say you balance in basic, you must introduce OH minus on both sides. Here now we have Br minus plus, I'm going to put my OH. Sorry, we're supposed to put a 2OH minus because we have 2H plus. So if you have, for example, as we have here 2H plus, we're also going to add 2OH minus, right? The number of OH minuses that we're going to add in a reaction is determined by the number of H pluses as well. If you have a 2H plus here, you're going to add a 2HO minus. If you have a 5H plus, it's going to be 5OH minus. So the number of OH minuses is determined by the number of H plus. So now we say plus 2OH minus. Okay, now we can now drop this one down. We say plus 2H plus, and next one we have our plus 2MnO4 minus. We put our arrow, and here we have our BrO3 minus plus 2MnO2 This is a neutral compound, plus H2O plus, remember we added 2OH minus. You can also add it here again, 2OH minus. Okay, if you add 2OH minuses on the left, you must also add the same number of OH minuses on the right. Don't add a 2 on the left and add 1 on the right. No, you end up getting an incorrect solution. Now let's proceed. Here we have our Br minus. I need you to understand something. Whenever OH minus, right? Suppose you have OH minus reacting with H plus, what's going to happen? This is going to give you H2O. It's called a condensation reaction where, for example, if you have an OH minus reacting with H plus, the byproduct is going to be water. So this is going to replace these two here. So we replace the OH minus and the H plus with 2H2O, because when they react, they're going to form water, or water is going to be the byproduct. That is how it is. And that's how the H minus, or H plus rather, will be eliminated from the reaction. Now let's do that. I'm going to clean this up so that we can continue with our solution. Right here, remember 2OH minus plus 2H plus will now give you plus 2H2O, okay? Based on the fact that if an OH minus reacts with a H plus, they're going to form water, or water will become the byproduct. Here we have plus, and we'll drop this one down. We have 2MnO4 minus. So we put our arrow. Here we have BrO3 minus plus 2MnO2 plus H2O plus 2OH minus. All right. Now let's continue with this. So what's the next thing that we're going to do right now? Well, at this point, we can also cancel what appears twice on both sides. Here we have H2O, okay, 2H2O on the left, and we have H2O on the right. So we can cancel this one here. We can cancel the one on the right. Okay, we can cancel this one here. Remove what appears on both sides. So when we cancel this one, we can cancel the 2, and we have a 1 left. Okay, always remember to cancel what appears on both sides. As we've cancelled the H2O, we remove 1, okay, because we have 1, okay, here. We're going to remove that 1 from this one, and we're going to be left with 1 here. Now, let's rewrite the expression again, or the equation again. We have Br minus plus, instead of writing a 2, we now write H2O, okay, plus 2MnO4 minus, you put your arrow. Here we have BrO3 minus plus 2M, okay, we're basically copying everything down, O2 plus, instead of writing the H2O, which we've already cancelled, you now ignore it and write 2OH minus. Like I said, whenever you're balancing for basic solution or in basic solution, your answer must have an OH minus, okay? Your final answer must have an OH minus, and this is it, okay? So you must make sure that your answer contains an OH minus, and that is what makes it basic. Without the presence of OH minus, it means that it's not in basic solution. Now let's go ahead and confirm our solution. Make sure you always count your charges to be sure that you're correct, and also count your atoms. Let's begin with the atoms. Here we have a bromine. We have a bromine. How many do we have on the left? We have 1 on the left. We also have 1 on the right, so it's 1, 1. We now have our hydrogen. How many do we have on the left? We have a 2 on the left. How many do we have on, this is a 2 on the left. How many do we have on the right? So these 2 affect the hydrogen. It means that we have a 2 as well on the right. Now let's look at the next one. We have our manganese. How many do you have on the left? We have a 2 on the left. We also have a 2 on the right. So it's 2, 2. Now for our oxygen, we have a 1 here, okay? And then we also have 2 times 4. That gives you an 8, which means for the oxygen, we have a 9 on the left. And how many do we have on the right? We have 2 times 2. That gives you a 4, okay? 4 plus 2, that gives you a 6. Then plus 3 here, that gives you a 9, which means that all our atoms are balanced. Now, how about the charges? If you look at this very closely, right here you have a -1 from the bromine, a -1. So the 2 multiplies the -1. So we now have -1 minus 2, that's equal to -3. We have a -3 on the left. And how about the right? This one here, right here, is a -1. And here we have 2 multiplied by the -1 attached to the OH minus. It gives you -2, and this is equal to -3. Hence, we have, for the charges, we have -3 on the left and -3 on the right. Therefore, this reaction has been balanced in basic solution. I believe you understood what I taught you, and I know you enjoyed the lesson. Hopefully in our next class, we shall talk more about redox reaction, and I believe you understand better. Thank you so much for joining us, and see you in the next video. Bye.